equivalent layer of between 300 meters of nitrogen and 3 kilometers of nitrogen. So if we only see a veneer, which we now know, what's going on? What Kelsey and I predicted in that paper is that if we saw steep topography on Pluto, and therefore we're seeing only a volatile veneer, then there must be internal activity that's dredging nitrogen up through cryovolcanism or geysers or some other process that's active into the present on this planet. Now, we haven't found geysers and we haven't found cryovolcanoes, but this is very strong evidence that will send us looking as we get more and more data across the surface of the close approach hemisphere to look for evidence of exactly these phenomena. Interestingly enough, that paper submitted in May was accepted today. How's that? And I should point out that the editor of the journal is only learning of the results we're telling you now because she's watching it. All right, well, that summarizes the primary things that we want to tell you about the data that landed just this morning. Each of these images and data sets have a lot more to tell us about Pluto's history and about small planets and how they are formed and evolved. I just want to make one more comment about Tombaugh Regio. You know, we could see the heart very far from Pluto. When we were still 70 million miles out and only barely resolving the planet, a little better than Hubble can do from 3 billion miles away, you can see that shining like a beacon. And because it's the brightest and most prominent feature on the planet, that's why we want to informally call it Tombaugh Regio for the discoverer of Pluto. One more hand for the Tombaugh.